So example 2 for 3.3, they give us this equal to that, and they ask, is this a solution? So once again, solution. So they give us this equation, this is equal to that, and they want to know, does 7 plugged in for x satisfy the equation? So there's a couple different ways to do it. If we just take the 7 and plug it in where the x's are, we could have this. So now let's go to the innermost parentheses. 9 minus 7 is 2. 6 times 7 is 42. Minus 4 times 2 is 14. Equals 106. And it is not a good habit to drop this, so I'm going to fill it in there. Now 42 minus 14. Oh God, what would that be? 42 minus 14. 12, so that would be 8, 2, so 28 equals 106. No, not a solution. Okay, so that's one way to do this problem, where we just plug in directly, but I would like to use the other legal rules that we have covered in class to show how you can do it another way. And what I'm talking about is, if we, before we plug in for x, if we just simplify this, we could distribute here. And you really should be able to do it either way, the way I showed already, or this way. 6x minus 4 times 9 is what, 36. And then negative times a negative is a positive 4x. 4 times x is 4x equals 106. And then these are like terms. So we end up with 10x minus 36 equals 106. And now let's plug in 7 for the x. $70 minus 36 equals 106. 70 minus 36, what would that be? 34. So 34 equal to 106. No, it is not a solution because that's not a true statement. And so that's just another way to do this using the rules that we've talked about in class, distribution in this case, and then combining like terms.